Hello folks, welcome to Land Tamer Stream. I'm finally back. We're gonna try to play with the music in the background. See what that does. Turn it way down though. Okay. Yeah, thanks for hanging out. It is Saturday night. It's a late Saturday night stream, and it wasn't really planned that way, but that's what it is. So we're back, and I've been away pretty much since last weekend. Probably it's probably been 9-10 days or so that I've actually streamed. So I've been in Discord every day. I've definitely been checking in with Discord. I've been checking in Twitter, things like that, doing a few posts here and there, but I've been really occupied, and it's been related to family. I had to travel, I had to take, airline flights, and I was working also all this week, just working remote at another family member's home. So regular work schedule. As a matter of fact, I learned a lot about Azure this week, as I do, seems every week, and cloud computing. That might be a little too loud. I don't know, it's a little distracting me, so I'm going to shut it down. Anyway, yeah, so that's been what's been going on. So I have not really been able to stream. I kind of let everybody know that, but anyway, I'm back. I'm back home. Back in my environment here, back in the comfort of all the screens I have in my lab. I've got my lab, everything, so I'm ready to go. And there is no countdown for a particular reason. I mean, essentially, it would be like, it is currently scheduled for November 12th, so it'd be like 20-something days. But that's just not going to fly because of these responsibilities I had to help out with, take care, and doing this last week, being away, not only was I working my normal schedule and learning things about Azure and having to work, there's one night I had to work from, I was essentially working from 8 a.m. to 2 a.m. the next day. There was an issue related to certificates, and certificates is not really much easier in the cloud than it is on premise, I'll tell you that. In some ways it's harder, in particular when you start looking at IaaS is pretty much the same, but when you start looking at PaaS services, Azure native services, and not working at a bash shell like you normally would for a Linux box, for example, and working with the Azure API or any other cloud API, I'm sure things look different, things interact differently, and it's not always as easy as what we're used to. So that was the case for me and other members of the team. So anyway, make a long story short, it was definitely a long week. And aside from all that, when I wasn't working my day job, and in some cases night job, I was also helping out family, taking care of some things that were needed for family members. So I've been very busy with that thing. Life happens, and you can't always, you have to react to it, right? Things you have to take care of, not going to wait for anything else, not going to wait for your study schedule. So it did put me behind, but I knew it was going to, and I counted for that. That's why there's no countdown, because I am definitely going to reschedule. And I've been talking with Dude for Him. This is one thing I did do while I was away, and that was he and I have been working together on Twitter, asking each other questions, preparing for the CCI written, testing each other's knowledge. So that has been really good, and that's actually going to lead to what the majority of this blog is going to be about, which is going to be brief tonight, but that is 6RD tunneling, IPv6 using tunneling using 6RD. And we've been going back and forth on all sorts of different subjects, questioning each other, challenging each other, So that I have had time to do, and I have been able to do. We're doing one question a day and talking about, when we're going to go ahead and take the written. Pretty sure he's going to do it by the end of the year. He has a date scheduled end of December. I will probably move mine to correspond to that. So that's why I don't have a countdown right now. I'll probably have that updated tomorrow. So that's the story where I'm at. Written progress. I am going to be, I again did not really have any time or energy for written progress at all using network lessons, but that is going to restart tomorrow. And we're going to get into that. So I'm going to go right to the trivia and some meat chunks for tonight, folks. That will pretty much be it. 6RD. So what are the, and this is my question to Dude for Him. This is going to be my question to you if you're watching this. For IPv6 6RD, what are the advantages and disadvantages of using 6RD over some of the other alternative tunneling techniques or protocols? So try to think of that in your mind. First of all, what is 6RD an acronym for? Well, it is IPv6 rapid deployment, right? What is 6RD tunneling? Well, there you go. It is tunneling. I kind of gave that to you. It is an IPv6 over IPv4 tunneling technique and protocol. So let's talk about that, right? And let's first of all make a comparison. Well, first of all, let's talk about the use case. So 6RD, first of all, is automatic tunneling. I say automatic in that really it's stateless. It's probably the better term. There is a distinction there, I think. You talk about, there is a term for automatic 6-to-4 tunneling. That is one technique that has its own name called automatic 6-to-4. So I don't want to muddy the waters too much there. I think there could be a question about automatic tunneling techniques, and I think what that implies is stateless. In other words, you typically think of tunneling techniques as either automatic or manual in one sense. So let's talk about 6-to-4 first. 6-to-4 tunneling. Automatic 6-to-4 tunneling. Generally, that is a specific type of prefix that you have to use, and it is 2002/16. So if you see this is a designated automatic 6-to-4 tunneling prefix, or can be used as a 6-to-4 prefix. And what it does is it's going to automatically translate or allow you to tunnel traffic between IPv6 islands, right, over an IPv4 network. So that is 6-to-4 tunneling, and it is stateless. So let's move on to what is the difference between that and 6RD, IPv6 rapid deployment. 6RD is also a stateless tunneling technique for connecting islands of IPv6 over an IPv4 network. However, one thing that it does different, and one reason that 6RD has been adopted by service providers to connect their customers, is because it does provide access to the global internet, both essentially the IPv4 and IPv6 internet. Now, automatic 6-to-4 tunneling also can provide access to the internet and is globally reachable, both towards the internet and traffic inbound from the internet. However, it's not really practical because if you think about it, if this is what identifies, and I'm going to go ahead and put it out here, right? Automatic 6-to-4 tunneling. if this is the globally recognizable prefix, and let me make sure I have that right here. I have actually a chart, folks, out in GitHub, and it is references notes. There's an IPv6 folder and IPv6 transitioning mechanisms. I think this is the latest one. What's happened there? Yeah, 6 to 4. Yeah, I should enumerate here. So it's 2002. This is the format. 2002 x.x.x.x /16. Is that right? No, /64. Sorry. Yeah, that's correct, because 16 bits is not nearly enough. So you have, if you think about this, you can have embedded in here an IPv4 address converted, right, to hexadecimal, and this would be 32 bits, right? But you have 2002 and /64. The thing is that you would have to use, with automatic 6 to 4, since this is a global, 2002 is global and is not unique, what happens is this is not necessarily going to be routed around the internet. Because, I mean, if you think of it almost as this 2002 prefix as sort of a, I mean, it's shared, right? So that's just not going to work. That's automatic 6/4 tunneling. And in reality, service providers have not adopted it for reaching the global internet. Yeah. If you think about it, so it's going to go to a service provider to route using a 2002/16. So think about assignment of prefixes, right? So who has 2002/16? No one owns that, right? So that is a universally assigned. So at some point, this is going to get to a point on the internet where you have to rely on pretty much everyone, all ISPs, advertising this prefix. So you could advertise it to all the well, hold on a second. I'm not explaining this very well. Think about 2002:/16. You could choose to advertise that across the internet and hope that other service providers who have customers behind this prefix would route that for you. But why would they? Because it's inefficient. We can't have all the ISPs sharing this prefix, and then it's up to them whether they choose to route it or not further to other customers. So it's not unique, and you cannot guarantee that your traffic is going to go in and out of the global internet. That is a problem with automatic 6 to 4 tunneling, right? So along comes 6RD, and 6RD is how it is different from automatic 6 to 4 tunneling is that it uses it's not restricted to this prefix, right? So what happens is you use a globally reachable assigned slash 32 IPv6 prefix plus, here's the address format. 6RD is IPv6 rapid deployment. And you can do automatic 6 to 4 automatic tunneling of IPv6 traffic over IPv4 backbone. Address format. Now this is, we're going to speak in generics here because there are some caveats here. That's what I'm going to say, right? But you have a globally reachable assigned /32 IPv6 prefix. So service provider gets a block of addresses. It's going to take a /32 and it's going to designate that prefix globally routable, but it's going to take that prefix and it's going to assign the other 32 bits. So let's say, let's do this. So 32 bits. Service provider, routable prefix plus 32 bits IPv4 compatible address. /64. Does that make sense? So you've got, instead of 2002/16, you are going to have a so let's find an example. I want to find one because I'm not, yeah, as you could tell, I'm not extremely confident in my explanation here. But 6RD tunneling packet. Let's just show you an example on a packet capture. Okay, here's a good example, right? So you got, does he show you how to, bear with me, folks. I'm trying to find. Well, let's just take, for example, your /32. ABCD. Let's go 2001, ABCD. And you have x.x.x.x. So as you can see, this first 32 bits, that is your global prefix assigned to ISP, Comcast, or whoever it is. Then you have IPv4, and this is going to be a dual stack router running this, right? And it will then, when it receives this prefix, traffic destined for the IPv6 prefix, it can then forward traffic inbound, right, to the customer behind its network. It can also take IPv4 traffic, right, inbound IPv4 traffic, and encapsulate it and tunnel it using its assigned prefix. So that is the advantage here of 6RD, and that is why this is what is often used for IPv6 tunneling by service providers. So advantages and disadvantages, I've kind of listed those out here. RADPID development. Automatic tunneling, we'll say stateless. Stateless is always good. And global reachability to IPv4 and IPv6 internet. Connects IPv6 islands or IPv6, not necessarily just only. Connects IPv6 customers using IPv4 backbone. The disadvantages are, this does get complex when you have, so, well, there are a couple disadvantages, right? Here's the advantages. Disadvantages, and let's put this up here. The disadvantages is that you essentially have to allocate or dedicate a /32 must be dedicated, and a lot of space it goes unused. So you take this /32 and you take the IPv4 portion, which is also 32 bits, and you know, there are a lot more IPv4 addresses that would fit in here. But I have to dedicate this entire /32 to a customer. So that is one disadvantage. Also, if I want to take a single prefix and assign it to a customer, there is a way to use multiple IPv4 addresses here, or address space here. So in other words, I don't have just one site behind the /32, but if I want to have multiple sites and still route within the site, you can do that, but it gets a little complicated. So in other words, to subnet the 32 bits compatible with IPv4 is a complex, can be a complex process. So that's the best I can do for right now, folks. I'm not, you know, the reaction I got from Dufresne, which I understand, is that this seems to be really service provider, and it really is. Oftentimes you're doing enterprise network, you're going to build 6-to-4 tunneling. I don't know what just happened here. I clicked something and I have no idea what I did. Anyway, if you're going to provision this inside an enterprise network, you know, you're not concerned about reaching the global internet, automatic 6-to-4 tunneling is generally what you're going to use. You just want to connect IPv6 islands on your network in a stateless fashion automatically, and you're not too concerned about, you know, reaching the internet. Maybe you're using some other mechanism to reach the internet. Maybe you're doing some sort of NAT in your IPv4 backbone and directing that traffic to reach the IPv4 internet. I don't know. But if you are concerned about, you know, connecting IPv6 networks and they need to access the internet, then it would be the way to go, 6RD. And this is what is being implemented in a lot of cases, rapid deployment. So I hope that helps folks with the advantages and disadvantages. I'm not claiming that I could go out and implement this right now. I absolutely could not. I have not labbed this. I don't know all the commands. I think if I labbed it, I would understand it even better. But I do, in a broad sense, kind of understand. I'm able to sort of compare the solutions and use cases and implementation scenarios, and I think that is what is really important for the written exam. So anyway, I hope this helps. I got a couple of meat chunks here. One is a great episode of Pack Pushers IPv6 Buzz. I've been going back and listening to a lot of these episodes. I did have some time to do that while I was driving around, running errands during my trip. And this is really good. And I tweeted about it because my thinking is, I've heard this a lot. We've talked about it in Discord, man, IPv6, assigning a /64 to an interface is just such a waste of space. And I get it. I understand it. I felt the same way. But studying a little more, and this podcast in particular is going to help you to kind of get over that. When you just stop and think about it, you can't just think about the way you would design addressing plans for IPv4. You have to let go a lot of design principles that you would use in an IPv4 network when you're designing IPv6, And they go into that in detail, and they do a really good job of it. I highly encourage you to listen to that episode. Also, this was a good report on why are people deploying IPv6. So in the last number of years, in particular since I think 2011, 2012, there's been a steady growth of IPv6 implementation to where now we're looking at generally on the global internet like 20% and up of IPv6 traffic, which is great. What is driving that? Well, the answer in short is we don't really know for sure. It's not always cost. It's not always competition. It's not always for speed. Check out this article and see what sort of conclusions they come up with. It's good stuff. So I hope that helps. That's going to wrap it up for tonight. I know I rambled a little bit on this one about 6RD tunneling, but if anything, maybe you'll get from it that, just like me, you need to study it some more, and we at least understand some of the concepts of where 6RD would be used and what scenarios. So thanks so much for stopping in. I know it's late. Probably not a lot of people caught this, and that's fine. We will be back on tomorrow, regular schedule, and through this week. We're going to start a countdown in earnest tomorrow. Probably do the reschedule tomorrow. And we're going to get down to it. So, sending good bits to everybody. Wishing you a good night. What's left of it. And we shall see you tomorrow here very soon. Hey, we got YYZ. Thank you, YYZ. I have to say, I know I'm scratching the surface, and the engineer in me wants to go deeper. I want to go lab it. I want to go, but I don't want to get down a rabbit hole. That's one of the my mentors told me after the fail of the written. He said, don't start labbing everything. Don't start going down rabbit holes. So I really want to. I'm so nerdy about IPv6 right now. I'm really enjoying playing with IPv6 and studying it, kind of seeing that theme. I would love to lab this. But yeah, for service provider, absolutely. I'm sure 6RD is pretty important. But yeah, route switch, trying to resist that urge. That makes me feel better. Yeah, no need to lab it. Thanks, YYZ. I appreciate it because sometimes I'm tempted to do it and I need to just hold back. So yeah, good to see you tonight. Hope you're having a good. Hope things are going well in your studies. I know you're taking a paced course, as I understand it right now, right? So wish you good luck on that. Thanks for tuning in, folks. We're gonna wrap it up. It is 000 officially right now. time-wise. And we'll see you folks in Discord and back to Land Tamer stream. Have a good night. You too, YYZ. Good luck. 2 weeks. That's awesome, dude. Man, it's been a while since we've seen each other now, since the Cisco Live. But yeah, thanks for hanging out in the chat. We'll see you soon. Y'all have a good night.